In this section, let's try solving some applied problems. Before we do that, there's some language that we need to make sure is clear. And that language is the difference between angle of elevation and angle of depression. So right triangle trigonometry can be used in a lot of, I guess, real world applications. The ability to determine the height of a tree without having to climb to the top and measure, or the ability to determine from the top of a building, say, the distance between two locations that are on the ground. These two examples are examples of angle of elevation and angle of depression. And let's see if this picture helps make sense out of that. So there you are standing, and if you look up at an object, then that angle between the horizontal line of sight and the object is called your angle of elevation. If, however, same person looking straight out at a horizontal, if you look down toward an object, that is your angle of depression. It's really easy to confuse angle of elevation and angle of depression. A lot of people think angle of depression maybe is this angle. So that would be, it feels like, oh, you're looking down, but that would be incorrect because in both of these cases, you start out looking at a horizontal, so you're looking straight out, and then you either look up or you look down from that value. This YouTube video will give you a little bit more examples of this if you find that you're running into trouble. So let's look at this example. We have a building, and it says to find the height of a building that is perpendicular to the ground. Cassie walks to a point 100 feet from the base of the building. She measures an angle of elevation of 19.3 degrees from her line of sight, which happens to be 5 feet above the ground. And that is to the top of the building. How tall is the building to the nearest foot? Okay, so the building is comprised of one side of a triangle plus the 5 feet that Cassie's line of sight is. So let me just mark that in here on the side. So we're going to have 5 here, and then let's just call the rest of it X. Okay, and that side X makes up one of the sides of the right triangle. So what I need to do to find out the height of the building is to find X and then add 5 to it. Now, in this right triangle, we know that the base of it has a length of 100. We know we're trying to find X, and we know that across from side X is an angle 19.3 degrees. So we want to find the side opposite, and we know the side adjacent. So we're going to use the tangent ratio to say that the tangent of 19.3 degrees, the tangent of 19.3 degrees is equal to X over 100. And I'm going to multiply both sides by 100 to get that X is equal to whatever my calculator tells me, 100 times the tangent of 19.3 degrees is. And when I put that into my calculator, I got approximately that X is 35.0195, and I guess we are in feet, so that would be feet. So how tall is the building to the nearest foot? The building is to the nearest foot. That would make my X value 35 feet. That would make my X value 35 feet. And remember that I started with Cassie's line of sight, which was already at 5 feet. So the building is approximately 40 feet tall. Let's take a look at another example. In this example, Emmett is sitting on top of a slide, ready to slide down to his mom. The angle of depression from the top of the slide to the ground is 46 degrees, and the slide has a vertical height of 9 feet. Find the length of the diagonal slide to the nearest 2 decimal places. Okay, I like to start with a picture because to me, I have a hard time visualizing just all these words. So I want to see as much as possible, can I draw out what's going on? So we have Emmett who is sitting at the top of a slide, and he is ready to slide down to, in this case, his mom. And I bet you've all had that experience of sliding down to someone ready to catch you. In this case, it's Emmett's mom. Okay, now you'll notice that I just formed a triangle, didn't I? What I'm hoping is that by drawing a picture, I draw some type of a shape that I can then just focus on that shape and not get so bogged down by the words. Okay, so the vertical height they told me of that slide was 9 feet. So this part right here is 9 feet. And assuming that the ground is, perfectly horizontal, I think the slide vertical height and the ground just formed a right angle. The angle of depression from the top of the slide to the ground is 46 degrees. Okay, here's the tricky part. It's not real tricky, but it's something that people do get hung up on. That angle of depression is looking out at a line of sight, a horizontal line of sight, and then looking down. Okay, so this is where that 46 degrees is at. Now, if I want to work with the inside of that triangle, then I need to determine the complementary angle. The complementary angle, this angle right here, is going to be whatever 90 degrees minus 46 degrees is. And I believe that that would be 44 degrees. 44. See if I can squeeze that in there. Okay, so the sum of two angles adding up to 90 degrees are called complementary angles. And we know that they sum to 90 degrees because I'm also forming a right triangle up here at the top when I do that. So what is it that I'm trying to find? Find the length of the diagonal slide to the nearest 2 decimals. So the diagonal slide in my triangle is really nothing more than my hypotenuse, isn't it? And in relation to that 44 degrees, the 9 feet represents the side that is adjacent to the 44 degrees. So I have the adjacent and I want to find the hypotenuse. The trig ratio that gets me that is the cosine. So I'm going to write that the cosine of 44 degrees is equal to the side adjacent over the hypotenuse. And I want to try and get that x by itself. So the first thing I'm going to do is probably multiply both sides by x, because I prefer to not work with the fractions if I don't have to. And so I get x times the cosine of 44 degrees is equal to 9. And I'm going to divide both sides by the cosine of 44 degrees. And I'm going to put that into my calculator, making sure that I'm in degree mode. And I get x is approximately equal to, I'm also going to round to 2 decimal places, and I get approximately 12.51, and that was in feet. Okay, so going back to the original wording of the question, find the length of the diagonal slide to the nearest 2 decimal places. I'm going to say that the length of the slide, is 12.51 feet. So by drawing a picture, we really turned a problem that maybe felt sort of wordy into nothing more than a triangle. And I would say that and the fact that we're talking about angle of depression are the two hardest parts about this problem. Angle of depression, remember, is always looking out at a horizontal, a line of sight. If it's angle of elevation, you look up, but if your angle of depression, you are looking down, always from that horizontal. So let's try another example. There is a lightning rod on the top of a building. From a location 500 feet from the base of the building, the angle of elevation to the top of the building is measured to be 36 degrees. From the same location, the angle of elevation to the top of the lightning rod is measured to be 38 degrees. Find the height of the lightning rod rounded to 3 decimal places if needed. Okay, so I have a building. I'm going to just draw a vertical line for the building, and in a different color I will put the lightning rods. This lightning rod is sitting on top, and maybe just to help I'll make that building be more of a rectangle. How about that? So this is my building. This is my building. And this is my lightning rod. Okay. What else? From a location 500 feet from the base of the building. So I'm going to go out 500 feet. 500 feet. The angle of elevation to the top of the building is measured to be 36 degrees. Okay, so from this point on the base, I'm looking up, right? I'm looking up, and that angle of elevation is, what did we say? 36 degrees. From the same location, the angle of elevation to the top of the lightning rod is 38 degrees. Let me use a different color here. So same location, but now I'm looking up to the top of the lightning rod. And that angle measure is 38 degrees. Find the height of the lightning rod. Okay, so let's see what we've got here. We're assuming that the building is perpendicular to the ground. They haven't told us otherwise, so we do have a right triangle. And actually we have two right triangles, don't we? We have the right triangle that is the building with the lightning rod. We have the right triangle that is just the building. I think what I'm going to have to do is I'm going to have to label a variable to represent the lightning rod. So maybe I'll say here, let's let x equal the height of the lightning rod, the height of the lightning rod, and that is in feet. How about if I I'll let the height of the building, I'll let that be b. B is the height of the building, the height of the building, and that is also going to be in feet. So I've got, let's see here, I've got x, I've got b, and now I'm going to need a height for both of those combined. So x plus b, maybe I'll call that a. That is going to be the height of both. So the height of the building, got a lot of writing here, of the building plus the lightning rod, and that's in feet. So I think what I can do is I can solve for b. I can find the height of this building. I think I can also find the height of a. I didn't mark a in there. These two together are a. I think I can find the height of a. So that's going to be this whole piece right here, all the way up to the top. And so then to solve for x, x is simply going to be, what is x going to be? X is going to equal whatever a is minus whatever b is. Okay, let's give that a whirl. Now the reason why I wanted to do that is because side b is part of a right triangle, right? And that right triangle has a base of 36 degrees. I want to find the side opposite it, and I know the side adjacent to it. So I'm going to say that the tangent of 36 degrees is equal to the side opposite, which is b, over 500 feet. And if I multiply both sides by 500, I get that B is approximately, so go ahead and put that into your calculator. I got approximately 363.27 feet. Now remember, in my final calculation, I'm going to use the exact number. So whatever you get in your calculator, I know it's not 363.27. There's going to be a little bit of rounding. In fact, let me just try that one more time because I cleared it. 500 times the tangent of 36 degrees is 363.271264. So I'd be using that exact value. Okay, so in my process of solving for x up at the top, x, which is what I want to find, I don't know a yet, but I know that b is 363.27 and all that change. So let's see, what else do I need to find? I need to find what A is. So A is the side of the larger triangle that has a base angle of 38 degrees. So same idea, but now I'm going to say, and let me just do that over here to the side, I'm going to say that the tangent of 38 degrees is equal to A over 500. And I'll multiply both sides by 500, and I get that A is, hold on here, A is approximately, I got 390.64 feet. And again, I know that that's a rounded answer, so I'm going to be really careful when I do this computation. The actual number is 390.6428133. So I'm going to use those exact numbers and do the subtraction to get that x is approximately, this is rounded to 3 decimal places, x is approximately, let me do approximately, 27.372 feet. It's a tall lightning rod, isn't it? So the question was, find the height of the lightning rod. I'm going to say the lightning rod is I'm going to say that the lightning rod is approximately 27.372, and that is in feet.